Dr. Larry Sutter is a professor emeritus at Michigan Tech University and also is the principal of Sutter Engineering LLC, providing consulting services on concrete durability and specifying concrete making materials. Currently specializes in supporting implementation of alternative cementitious and supplementary cementitious materials. He's also a fellow of ACI, a director on the ACI Board of Direction, chair of Committee 321, Durability Code, which he'll be speaking about today, board member for the ACI Center of Excellence for Carbon Neutral Concrete. Dr. Sutter.
Thank you, and I would definitely heed Mike's advice on using your judgment with anything I have to say. I know I would. Okay, so durability requirements. So we all know, ACI is definitely one of the key things that we do at ACI is write codes. That's one of our main products, one of our main IP, if you will, and we're known worldwide for that. We have many examples of codes out there that I'm sure many of you are familiar with. Obviously, 318 is the most well-known code, but there's a whole variety of codes. The last number I heard, as I think if I got it right this morning, was there's 37 codes or code writing committees out there. So basically 37 codes either out there or in development. So there's a lot of new codes being developed, as Mike talked about. The codes, as we all know, are developed by standalone committees. And each committee has a jurisdiction over one code. And the interaction between these committees historically has been quite low. And that we're trying to address by establishing a code advisory committee. It's going to start having these code chairs and the code committees meeting and working together and start trying to find ways to integrate better and certainly to reduce conflicts, which we'll talk a little bit about in a minute. And so, this process is going on. It's a new process. It's a burgeoning process. It's a growing process. There's going to be growing pains, and we're moving forward with it. The durability code is a little bit unique in that it's more of a cross-cutting code. But the whole idea here of a lot of these new codes is to develop them to be referenced by other codes. So, for example, 318 may want to reference the durability code. Or to be a standalone document. So it can be referenced in construction specifications, possibly in a situation where 318 isn't being used, but durability is obviously something that still needs to be specified. And that is something to be considered because, although 318 is cited for many projects, there's some projects where 318 may not be the applicable code or the best applicable code to be using. So be able to use this in a standalone manner is important. So durability is something we're all very familiar with, and a durability code is something we've talked about for many years. And durability, this whole process of a durability code has not come without detractors. And concerns have been expressed about conflicting with other codes where durability is already being specified in some manner. Others are concerned about providing too much prescription, that we're going to be imposing something on existing committees by developing this code. Adding complexity. One of the things that we've talked about is the idea of a durability expert, which is something that doesn't currently exist in any of our codes. Is that something we're going to start doing? And then, of course, there's always issues of jurisdiction. How is it going to be applied? Who would adopt such a code? And how would such a code be enforced? So, with all this as kind of background, and we've been working on the code now, I think since 2019. We had a very slow start because right after our committee formed, COVID hit. So the first 2 years, we went 2 years without ever meeting face to face. So we got kind of a slow start on the process. But we're starting to pick up steam now. And a lot of these things have been discussed over the years, and I'm not going to say that we've resolved them, but we certainly are aware of them, and they're being discussed, and they're being discussed not only in the context of this code, but other codes as well. So these are some of the more cross-cutting issues, I think, not specific to the durability code, but I think the durability code kind of became the poster child for many of these things initially. So why durability? Why a durability code? Well, the reason concrete is used primarily, well, not primarily, but certainly a product that we look for in concrete, or a characteristic we look for in concrete, is long life and durability. So it really doesn't really matter what you're building out of concrete. Long life and durability is something that you expect. And so this is a cross-cutting theme across everything that we do in the concrete world. And so as we move forward with this whole durability code, some other things to be considered is, can we achieve durability and at the same time achieve lowest cost and shortest duration and so on and so forth. And again, these are questions that are being discussed, and I guess to some extent they kind of are a background for our work, but they're not. They affect our work in the sense that we think about these things, and as we try to move forward, make sure things are going to be compatible and adaptable. But nonetheless, this is the environment that we're working in. We have a new challenge here recently with low carbon concrete, and there's certainly a lot of discussion about low carbon concrete and will it be durable as we start looking at new cements, reduced cementitious contents. Are we going to be sacrificing durability? Again, this is all a backdrop that we're operating in. And I guess another thing that's out there is how do we balance these? If a LDP is charged with building a structure and we have a structural code and we have a durability code and they're both enforced, which one rules? So we have a lot of work ahead of us. It's going to be job security for whoever is going to be continuing on this committee after we're done with this first round. But this is kind of the background that we're operating in. I guess trying to provide this scenario so you understand that it's a little bit more complicated than sitting down just trying to figure out what makes durable concrete. There's many other aspects to this conversation that are factors in how we move forward. So this is an outline of the document as it currently exists, and the 9 chapters are listed here. The first 3 are really just boilerplate. Then we have a materials chapter, and then chapters 5 is durability planning, 6 is exposure categories, 7 is our design requirements, and then 8 is construction and quality requirements, and chapter 9 will be maintenance requirements. And today I'm really going to only highlight these middle 3 and just give you a little bit of background on those. That's really the heart of this document, in my opinion. That's really going to be the driving force behind it. So just a brief overview of those aspects. Durability planning is something that if you start looking at some of the European codes or the Australian guide documents that are out there, it's something that's there. It's not necessarily something that we talk a lot about over here in our construction, but it's obviously something that many would argue has been lacking, and it's a big part of what we need to do to move forward and have durable structures. The planning process is really to assign the appropriate exposure classes and categories for the elements being discussed. And then from there, a plan on things such as the materials to be used, the design methodology, construction practices, and so on. And one thing to keep in mind as we move forward is that, and this document is being designed with this in mind, is that it's not a one-size-fits-all situation. Depending on the type of structure, the value of the structure, you may do more or less in terms of how you pursue the durability planning and durability execution process. So, I mean, it has to be flexible and it has to be able to allow for these different types of structures to be accommodated. We can look at durability as it applies to the whole structure, or you can think about durability as it applies to elements of the structure. And the code has to be flexible enough to allow for that to happen, and that is being considered as we move forward. And another thing that we have discussed is really how to deal with the issue of changing exposure categories, exposure conditions, I should say. And because there's really, in some instances, you know it's going to happen over time. The exposure conditions are going to vary for that structure. So how do you deal with that? It's a difficult thing to put in any sort of mandatory language, so it's something we're dealing with in the commentary in terms of the durability planning chapter. Service life is another thing that we spent a lot of time talking about in the early ages of this committee, and we probably spent a year or more just talking philosophically before we even got anything on paper. And this was one of the issues we discussed. And this term enhanced durability was introduced right at the very beginning of our existence. And I personally have always had an issue with this term, enhanced durability. I keep thinking of Yoda and this idea, well, how does the saying go? How's the saying go? No, you or do not. There you go, do or do not, there is no try. And that's really the same thing with durability. Either you produce durable or you don't produce durable concrete. I mean, it's not like you kind of are durable, or this is really special durable, enhanced durability. So we went around on this for a long time and really came to the conclusion that there is really no such thing as enhanced durability. There's durability. And so we're writing a durability code. The code tells you how to make concrete as durable in those exposure conditions. And it's not a matter of being enhanced or being lesser or more or anything of that sort. And so the LDP then has to define the design criteria for service life and move forward. And really the only area where we felt that there was really good tools to do that, a service life design, is in the area of corrosion. So that's the only area where we're going to have any sort of service life prediction, if you will, I guess for lack of a better word. And service life design requirements for degradation mechanism other than corrosion are not going to be within the scope of the document because it simply can't, we really don't have a way of doing that. When a service life design is performed, again, for a corrosion situation, the methodology used for doing that needs to be reported as part of the durability plan. So the licensed design professional is going to establish the basis of the design to meet the requirements of the code. So this is going to cover many things, obviously cover corrosion, different materials that are going to be used. And then further, they have to develop the plan for executing durability. So this is going to have impacts on construction. So there's going to be a section on construction. So this durability planning section is going to interface with the construction section in terms of providing the overall guidance for what needs to be established. And as I think we all know that once it's built, you have to maintain it. So we felt that we really can't be silent on this particular aspect of the issue, so we do have a maintenance chapter. And the durability plan has to lay out how do we envision, how does the maintenance plan interact with the design is going to be ultimately established. The maintenance or the design is ultimately established is going to assume some level of maintenance. And so that has to be stated and it has to be provided to the LDP to understand what's going to be done. And then a birth certificate is something you see in many other codes, provides the owner with confirmation of the as-built structure and establishes that it meets the minimum durability requirements of the design. Chapter 6 is the exposure categories and classes. This chapter is the chapter that we have actually completed. And I just have here a summary of the various exposure categories and classes that we have developed. The class F and the class S are exactly the same as what's currently in ACI 318. The P category is new, physical sulfate attack. And then we have taken a different approach to corrosion. We have a corrosion based on carbonation, corrosion based on exposure to de-icing chemicals, and then seal corrosion due to the marine environment exposure. So 3 different levels of corrosion being considered in the exposure categories. And then we have also added the category E for erosion and abrasion. Chapter 7 is durability design, and the durability design is going to take that information that we have from the plan. We've gone through the plan. We understand where we're going in terms of the maintenance, in terms of the, everything that has to be considered to build up to the point of what the exposure conditions are, exposure categories are. And from there you move forward and you develop your design to achieve durability. You consider things, this is obviously just a very short list, things like cracking, your reinforcement cover, the permitted materials that are going to be used, and detailing of the structure. And so on. So the durability design chapter is what you're going to walk you through. How do you take this information you've compiled in these other sections and put it into a design that you can execute? And so, and I mentioned earlier, there's going to be interaction between what happens in these first few chapters and then the later chapters of construction and maintenance requirements. So the code is still under development, obviously. Our tentative schedule is to have every chapter balloted by June 2025. We have balloted every chapter once except for the construction chapter, and after this meeting we should be in a position to ballot the construction chapter. And so at that point in time we'll have balloted every chapter once. Many of these chapters we've balloted many times, or at least more than once, I should say, not many times. As I said, chapter 6 on exposure categories, that one has been finalized and is in the can. So we're moving forward, and our goal is to have a refined document by the end of 2025, and hopefully by this meeting, the spring meeting in 2026, it will be in the hands of TAC. And we'll be going through the TAC review, and then after that, obviously you respond to TAC comments and deal with those, and then go into the public review phase and move forward with it. So the intent is to try to have this document completed by the end of calendar year 2026. And that's our goal, and we're sticking to it, on time and under budget. This is going to be the first version of this document. We started out with a blank piece of paper. We didn't have anything else to work from, and we've worked through a lot of issues. We have a lot of issues yet to work through as we move forward and implement this document. But it's going to be the first version. There's going to be things that you're going to say, well, why didn't you do this? Why didn't you do that? And the reason we didn't do this or do that is because we want to get this done before we are all old and gray. So we need to move it forward and get a version done and get it out, and then start working on the next version. This is going to be a work in progress. Just like all of our codes, I mean, 318 evolves over every code cycle. There's new additions. This one's going to be no different. We're going to be adding to it. There's things that we want to add as we move forward. Chemical attack was one thing that we talked about early on, and we realized that we just didn't have enough information to even begin approaching a chemical attack in this code document. So we kicked that back to 201, and we said, give us some information. 201 has been working on it. They're very close to balloting a new chapter, including exposure categories for chemical attack. So once we have that, and we can look at it and see to what extent we can implement that into code and move it forward. So that's another one. Modeling is another one that we, again, in terms of corrosion, we could see the role for modeling, and we have a path forward there. Are there other ways to implement modeling? Again, we've talked about these things in the committee, and we have strategically decided to allow that for the next version and move forward with what we can do now. So those are all aspects that that will be there for the next version to be developed. Implementation is obviously going to be something we have to give some thought to, but step one, get the document done, and then step two is figure out how we're going to move it. There's going to be instances where this document will be referred to in a standalone manner, but my expectation is it's primarily going to be used in reference in other documents. And hopefully the other committees will look at this and say, hey, they did some work for us, they saved us some heartaches, they figured out how to deal with durability, they gave us some good information, we're going to use it. That might be a pie in the sky view of things, but that's what I'm hoping happens, you know, that we get that level of cooperation. But nonetheless, we're moving forward, and that's where we're at. So happy to take any questions.